Hey everyone! Today we're going to learn how to build a frequency distribution from a data set. We'll also learn how to calculate relative frequency, cumulative frequency, and cumulative relative frequency. Let's get started. Frequency distribution is part of descriptive statistics. It's a way to organize and summarize a data set. Here we have a table that shows 50 answers to a survey question. How many children do you have? Just looking at the table like it is presented, we can't really draw any conclusions or get any useful information from this survey, since the data is all disorganized. So our first step is to organize this data in ascending order. Now that the table's sorted, we can get a better sense of things. At the very least, we can easily spot the minimum and maximum values. Looking at the data, what values does the number of children range from? From 0 to 5. So in this data set, the number of children can only be 0, 1, 2, 3, 4, or 5. Now, what are we going to do? We're going to organize this data into a frequency distribution. What is a frequency distribution? It's a table that lists each category in the data, along with how many times it occurs. We've got 6 possible values for this variable: 0, 1, 2, 3, 4, and 5. So we have a table with 6 classes. In the first column, we always put the variable, in this case, number of children, and its possible values. And in the second column, we'll fill in the frequency. What is frequency? Some textbooks call it just frequency. Others call it absolute frequency. It is the same thing. Frequency is how many times a value shows up in our data. So we need to count. How many times does 0 show up? How many times does 1 show up? And so on, all the way up to 5. So let's start counting how many times 0 appears in the data set. 1, 2, 3, 4, 5, 6, 7, 8. 8 times. So the frequency of this class is 8. Now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 times. 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 times. 3, 1, 2, 3, 4, 5. 5 times. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times. And last, 5, 1, 2, 3, 4, 5. 5 times. So now we've managed to boil all 50 data points down into one simple table. And now, we can already say something useful about our data. For example, 1 child is the most common answer among these 50 families. But frequency alone doesn't tell the whole story. That's where relative frequency comes in. If you're enjoying the content, don't forget to subscribe to our channel. It really helps us grow. Relative frequency shows the proportions, or percentage, of observations in each class, and we calculate it by dividing the frequency of each class by the total number of observations, or total frequency, however you want to call it. So, in the first class, the frequency is 8, and the total number of observations is 50. 8 divided by 50 gives us 0.16. For the second class, we take 13, the frequency of that class, and divide it by 50, 0.26. The third class, 8 divided by 50, 0.16 again. Fourth class, 5 divided by 50, 0.10. Fifth, 11 divided by 50, 0.22. And finally, 5 divided by 50, 0.10. We can leave these results as proportions, like we just did, or we can convert them into percentages, simply by multiplying by 100. So, multiplying each proportion by 100, we get 16%, 26%, 16% again, 10%, 22%, and 10%. So, relative frequency works either way, as a proportion, where you just divide frequency by total observations, or as a percentage, where you do that same division and then multiply by 100. And here's a handy way to check your work. Add up all your proportions, and they should equal 1. Or if you're working in percentages, they should add up to 100%. So far, we've only looked at each class on its own. But sometimes what we really want to know is how many observations fall at or below a certain point. That's exactly what cumulative frequency tells us. How do we calculate the cumulative frequency? Cumulative frequency is the sum of the frequencies of every class up to and including the class we're looking at. In other words, the cumulative frequency for a class is the sum of the frequencies of all previous classes plus the frequency of that class. For the very first class, there's no previous class to add, so the cumulative frequency is just its own frequency, 8. From there, we just keep adding. For the second class, we take 13 and add it to 8. Why do we use 8 directly here? Because the cumulative frequency of the previous class is already the sum of the frequencies of all the classes before it. So all we need to do is add the frequency of the current class. That gives us 8 plus 13, 21. Now the cumulative frequency for the third class is 21 plus 8, that is 29. For fourth class, 29 plus 5 is 34. Fifth class, 34 plus 11 is 45. And the last class, 45 plus 5, brings us to 50. And here's the key check. The cumulative frequency of that very last class always has to match the total number of observations. According to this table, we could draw this following conclusion. 21 families have, at maximum, 1 child. Last but not least, we're going to talk about cumulative relative frequency. It works exactly the same way as cumulative frequency, except now we're accumulating relative frequencies instead of the raw counts, adding up every relative frequency up to and including the class we're on. So just like before, the first class simply repeats its own relative frequency, 16%. For the second class, we add 16 plus 26, which gives us 42%. Then 42 plus 16 is 58%. 58 plus 10 is 68%. 68 plus 22 is 90%. And finally, 90 plus 10 brings us to 100%. And once again, here's your check. The cumulative relative frequency of the last class always has to add up to 100%, or if you're working with proportions, to exactly 1. That's all for today. If you enjoyed the video, don't forget to leave a like and subscribe to the channel. And don't forget to turn on the notification bell so you know when new videos are posted.